This is my introduction to science. So, what even is science? Science is the systematic study of the structure and behavior of the physical and natural world through observation and experimentation. There are three categories of science. There is natural sciences, social sciences, and formal sciences. Natural sciences includes physics, chemistry, and biology. Social sciences include psychology and sociology. Formal sciences include mathematics and logic. Just for the sake of my own sanity, I'm going to focus on natural sciences since there's a lot to go up with that. So this is mostly going to be about natural sciences. So the major branches of natural sciences are chemistry, physics, astronomy, earth science, and biology. Physics is the study of matter, fundamental forces of nature, and energy. Chemistry is the study of substances, the property of substances, and how they interact. Biology is organisms and organisms' interaction with the environment. Earth science is the study of Earth's structure, properties, history, and processes. Astronomy is the study of celestial objects and the universe. Interdisciplinary science is pretty much when you combine two different sciences together. So if I were to combine biology and chemistry, I'd get biochemistry, which is combining biology and chemistry to study living organisms. If I combine astronomy plus physics, I get astrophysics, which is combining astronomy and physics to study celestial phenomena. If I were to combine many sciences, like a lot of science, and environmental issues, I would get environmental science, combining multiple disciplines to understand and address environmental issues. An example of an interdisciplinary science is the Human Genome Project, a collaboration of biology, chemistry, computer science, and mathematics. Let's talk about experiments. Most experiments are based off a series of steps called the scientific method. The scientific method starts with observation, noticing and describing events or processes in a careful, orderly way, usually using one of your senses. Observation goes into hypothesis, which is a testable prediction or explanation. It's what you think is going to happen. Then you experiment, you test the hypothesis through controlled experiments. You analyze, you do an analysis, interpreting the data collected during the experiment. You conclude, you draw conclusions based on that data. And that's usually it. Usually. But there's something else I'd like to add that not many people talk about, and it's communication. Sharing your results with the scientific community. On the topic of experiments, let's talk about the roles of experiments. You have controlled experiments, variables, reproducibility, and many more. Controlled experiments are testing hypotheses under controlled conditions. Variables include independent, dependent, and controlled variables. And redeductibility is importance of repeating experiments to verify results. An example that follow these are famous experiments like Newton's laws of motion and Mendel's P-plant experiment. Tools and instruments in science. You have a microscope used to observe small objects and organisms. Computer models used to simulate in complex processes. And you have telescopes used to observe distant celestial objects. Some notable scientists include Isaac Newton, who discovered the laws of motion and universal gravitation, Marie Curie for pioneering research on radioactivity, Albert Einstein and his theory of relativity, Charles Darwin and his theory of evolution by natural selection, and Rosalind Franklin for her contributions to the understanding of DNA structures. Applications of science. Science can be applied to many things, including health and medicine for vaccines, antibiotics, and medical imaging. In technology, like smartphones, computers, and the internet. And the environment, like renewable energy sources, waste management, and conservation. It can also be applied to daily activities, like cooking, cleaning, and transportation. There are some challenges and ethical considerations, though, when you're doing experiments, like human and animal testing, securing funding, ensuring objectivity and integrity, and effectively communicating. Why is science important? Science is important for 4 key things: advancements in technology, medical innovations, environmental protection, and knowledge and curiosity. Advancements in technology are development of new technologies that improve quality of life. Medical innovations like discovery of treatments and cures for diseases. Environmental protection like understanding and mitigating environmental issues. And knowledge and curiosity, satisfying human curiosity and expanding our understanding of the universe. Here are some things that might happen in the future. Emerging fields include nanotechnology, biotechnology, and artificial intelligence. Global collaboration, international scientific cooperation, and big science projects. Sustainable development by addressing global challenges through scientific innovation. And here are some further learning resources, including Khan Academy, Coursera, and edX, and books including A Brief History of Time by Stephen Hawking and The Selfish Gene by Richard Dawkins. Some websites you might want to go to are NASA, National Geographic, Science Daily. So you can also look at local and national institutions for museums and science centers. Thank you for watching. This is my second video, and this is my introduction to science. Thank you for watching.